Hi, welcome to video 2.2b. We're going to move on now to formulas for the derivatives of trig functions and different differentiation strategies. So, the derivative of sine x is cos x. The derivative of cosine x is negative sine x. Here's the proof out of the book. Again, they say, the AP says you're responsible for this. I've never seen them ask this question. But you should be able to follow it. It's just that there's a step you would never think of doing on your own. So, obviously, our f of delta x, if we're dealing with sine x, is sine of x plus delta x minus f of x, which is sine x. And now they use the sum property of a sine. Remember, the sine of a plus b equals sine a cos b plus cos a sine b. Then what they do is they rearrange things a little bit. They do leave this. They take this second term, move it to the front, and then they have minus sine x plus sine x cos delta x. They purposely factor out a negative sign, so negative 1 times sine is negative sine x, and then negative 1 minus cos x, negative sine x times 1 minus cos x would give, you'd multiply the negative sine x times negative cos delta x, which would give you sine x cos delta x. So not something you'd think of doing. At that point, then they split it up again. There's a monomial denominator here, so it's like you have a minus b over c, and they're rewriting it as a over b minus b over c. Sorry, a over c minus b over c. So they do that, and they purposely put this together, and of course, hopefully you'll recognize why, because we learned those theorems about the limit as theta goes to 0 of sine theta over theta, and also the one that we have about the limit as theta goes to 0 of 1 minus cos theta over theta. So what happens is they break that up. Now this limit is as delta x goes to 0. There's no delta x here, so that can just be pulled out. And of course now there's that famous limit that we all know. And then here, the limit of sine x, the limit is delta x goes to 0 sine x. There's no delta x, it gets pulled out. And then we have the limit of this. And of course you should know this limit is 1, this limit is 0, and there's the proof that the derivative of sine equals cosine. The most common mistake, of course, is forgetting which one is the negative. The derivative of sine is positive cosine. The derivative of cosine, if you perform the same procedure, you would end up with negative sine x. Okay, so don't forget that negative. So in numbers 3 through 24, it says use the rules of differentiation. In other words, you're not using a calculator and you're not using the limit definition, thank the Lord, to find the derivative of the function. So again, we always want to rewrite things before we start. I'm going to cube this 2x. I'm going to have to rewrite this as x to the power of negative 3. And then I'm taking the derivative of 2 cosine x. Remember, I could pull the 2 on the outside. Then I have the derivative of cosine x, which is negative sine x, which when multiplied by negative 1 will be negative 2 sine x. Here, of course, we multiply the exponent by the coefficient, subtract 1 from the exponent, and there's your answer. Now be careful here. They gave you y equals. You should not write f prime of x equals. You should write dy dx equals, or this notation right here. Also, notice how I'm using different colors. Both of these lines are the original function y equals. It is at this point that I'm taking the derivative. Do not try and tell me that a function equals its derivative. This is the function y. This is really a function dy dx, a very different function from y. So be careful about that. And all I did here is multiply the positive by negative and put that on the bottom. Now, it would be nice, but that is not the case. The derivative of the product of two functions, unfortunately, is not the product of the derivatives. You can't just take the derivative of the first one times the derivative of the second one. Similarly, it would be nice, but it is not true. The derivative of a quotient does not equal the derivative of the numerator over the derivative of the denominator. Now, we will have a product and quotient rule in the next section. In the meantime, though, as you know, 2 plus 3 over 10 can be rewritten as 2 over 10 plus 3 over 10. So what we can do with a quotient is rewrite it as each one of the terms of the numerator, each one of them over the denominator. do be careful that you do not assume that that works for the reciprocal. A over B plus C does not equal A over B plus A over C. But A plus B over C does equal A over C plus B over C. So here's page 115, number 46. In that this is a monomial, we are able to split it up. So we have the first term of the numerator over the denominator x minus the second term over x plus the third term over x. We then rewrite those. Simplifying, that'll give 2x to the 1. The x is canceled. We write this as x to the negative 1. And now we're ready to take the derivative of the function. Derivative of 2x is 2. Derivative of negative 3 is 0. And the derivative of x to the negative 1 is negative 1x to the negative 2, which gives you that expression, or there it is as a single fraction. Okay, so do be careful. Do not think that you can take the derivative of the numerator over the derivative of the denominator. That is wrong. So here's number 48. It looks like this, and of course what's missing there that you know is implied is that there is a multiplication sign between that 3x and that 6x minus 5x squared. Again, do not think that you can simply take the derivative of 3x and multiply it by the derivative of 6x minus 5x squared. That will not work. So what we have to do now is we'll distribute. Later we can do the product rule, but actually in this particular case it's easier to just distribute. And now, of course, it's very easy to find that derivative. Here's another one. Here now we're finding the slope of the tangent line, which is the derivative at a particular point. In number 2a, they give you y equals x to the negative 1/2. The derivative dy dx is negative 1/2 x to the negative 3/2. And now what we're going to do is we're going to take this derivative and evaluate it when x equals 1, because we're finding the slope of the tangent line, or the derivative, at the point 1, 1, which is where x equals 1. Replace x by 1, and there it is. Okay, so again, just a reminder of how you would do that on a calculator. The when goes on the outside, and you find it by pressing Control equals. And that's the end of video 2.2b.